All right, to save time, I'm going to skip over example 8, and then I'll come back to that later on if you want me to like in class or something. That's what I can actually come back and show you that the work for that. But I'm going to jump down to examples 9, 10, and 11 so we can go ahead and get through this part so we can be done. So here it says by utilizing the rules of logarithms and implicit differentiation, you can turn an exponential equation into an equation involving logarithms that is usually easier to deal with. So here we have an exponential function here, 2 to the x power, y equals 2 to the x. And so they want us to go ahead and change it to the natural log and see if we can get the answer. And when we do it, it's going to end up giving us the actual derivative of a function, exponential function with a base that's a number and the exponent of x, or exponent of any other function. So we're gonna end up deriving the function, this part down here where this came from. So here, if we're going to do this, deal with our exponential functions, and again, hopefully either in one of your math classes, previous math classes with natural log and logs, that you've learned how to solve an exponential equation. The first step is to go ahead and pretty much make sure that exponential function is by itself, which it is. So we take the natural log of both sides. Oops, sorry, natural log, ln. All right, at that point, then we either take use the power rule, or we use natural log and e to cancel it out. Here we're going to use the power rule because there's an exponent here. There's no e. So we use our power rule for logs. We're going to move the x in front. So it means natural log y equals x natural log 2. All right, so we're going to take the derivative here. And again, natural log 2 is a constant. It's a number. And so it's not, when we take our derivative, we're not going to actually find the derivative of natural log 2 because it's a coefficient, really. So we're going to leave that part and find derivative of just x. But again, to find derivative of y, implicit differentiation. So here, find derivative of both sides here. So d dx of all of this. This will be 1 over y dy dx. And this is 1, derivative of x is 1, times the natural log 2. Because remember, natural log 2 is the coefficient. So we really can't do anything with that. So here, that leaves us really with, here if we get rid of, get dy dx by itself, that means we have dy dx equals natural log 2 times y. 1 times natural log 2 is natural log 2, and then multiplying both sides by y gives us y. Now again here, we cannot keep y in the problem. Well, it's best not to, so let's go and substitute what we know y is. So from the original function here, we know that y is equal to 2x. So here, natural log 2 times 2x, or to write, well, just keep it like that. And really, that's what our formula is going to be. It's going to be natural log of whatever number it is times 2 to whatever the exponent is. So that's pretty much times the derivative of whatever the exponent is. So here, we're going to do the same thing here for this part here really quick. Fly through this one because we just did one just like it. So again, exactly as we did, take the natural log of both sides, ln 3x, do the power rule of logs. Again, we take derivative of both sides here. That'd be 1 over y dy dx. And we get 1 times natural log 3, because natural log 3 is a coefficient. And so here again, we get dy dx equals natural log 3 times y. And then again, we substitute this in for y. And so we get the derivative dy dx is natural log 3 times 3 to the x power. And again, that brings us back down here to this formula, which is the natural log, the derivative of a to the u power, which a is a constant, like it says right here, a is a constant, just like 2 is a constant, 3 was a constant. So a is a constant here. And so here, whenever we take the derivative of it, it's going to be natural log of the constant, times the constant times u, whatever the u function is, times the derivative of u. And so again, this is times u prime. So just rewriting it again, it's natural log a times u, a to the u, sorry. Horrible. Times u prime. Okay, so that's that formula. So we derived it. So it's important to know those formulas. All right, so last thing is example 11, and then we are done, and I can give you the homework. All right, so we're going to find derivative of this function of g of x, and if you look at each one of them, there's the exponential function, there's an another exponential function with a constant here as a base, and then it's the natural log. So we're going to find derivative of each piece, of each portion of that. And again, because it's a sum, we can find derivative of this, find derivative of this one, and find derivative of this one. So that's what we're going to do. So d dx of e to the 5x plus d dx of 7 to the x power plus d dx of natural log x cubed plus 4. Okay, so we know here, this part here is actually u, so that's e to the u, and u is 5x. So that means it's going to be e to the u times u prime. And so u prime here is just 5. So that's e to the 5x times 5. For this second portion here, automatically we know that's going to be the natural log of 7 times 7 to the x power times u prime, which is just, let's do this part, sorry. Let's do this part. Let's write it out in formula form. Let's say u prime here too. So here we know that's going to be natural log 7 times, times 7 to the x times 1, because derivative of x is 1. Right? And then the last part here, it's 1 over u times u prime. And so here, the u is, so we get natural log u, sorry. Oh, you guys can't see that part, my fault. Here we go, sorry about that. So here, we have natural log u, then u is going to be x cubed plus 4. And so here we take the derivative of u, which is 3x squared. Right, so here that'll be 1 over x cubed plus 4 times 3x squared. Right, then we just simplify everything down and we are completed, done. So we get 5e to the 5x plus natural log 7 times 7x, so 7 to the x power, plus 3x squared over x cubed plus 4. And that is the derivative of g prime. So we took everything we talked about in this lesson and put it all into one problem, and we got an answer. Isn't that great? Yeah. All right, so your homework will be page 170, numbers 1, 5, 9, 15, 19, 27, 37, 41, and 49. Have fun.